Hello, I'm Dustin Hoekstra here at the AWR-NI booth at IMS 2018 in Philadelphia. I'd like to show one of our new features in the upcoming release, V14 of AWR, due to be out in August 2018. Here's a little sneak preview at some features we added for PCB import and EM solving. So I'd like to start off with this page where I open up a blank project and open up what we call our PCB import wizard. And basically what this does is it allows me to point to an XML file, and this is using an IPC 2581 format. We do support 3DI as well as ODB++. And once I point to that file, I can specify which layers I want to import. So I checked a handful of metal layers, which nets I want to import, picked them all, and also shows me my stack-up information that I'm getting from that IPC 2581 file. So I click on OK for all those wonderful things and does a little bit of math magic behind the scenes where it imports this file, and now I have a layout of my whole board ready to go. Now the objective in this situation is we want to do an EM simulation on part of the board. So the part we're interested in is actually way up here, and you can see kind of faintly through there's a lot of overlapping traces that are running between these pins. So what I'll do to go to my next step, and pardon me while I scroll up to step number 2, is essentially cutting out that area of interest. So the easiest way to do that is to go to this other wizard we call PCB EM setup. So I'll double click on that, and kind of what I did in preparation of this, there were a whole bunch of pins up here, and rather than sit through and me clicking all 20 of them, I'm just going to hit the restore button right here, because beforehand I selected all those pins. So all those pins are now selected. That's a little behind the scenes magic. Anyway, now I click the Smart Select button, and what that's going to do is it's going to select all the nets that are connecting these pins right here. So now I have these areas that I'm going to all these nets that I'm going to EM simulate. So next step is to say set up EM doc, and it's going to ask me a question about visibility of layers, and I'm going to say yes, that sounds fantastic. I'm going to go with that. And now it's going to say what kind of cutout style you want. By default, we're using a bounding box. You can see this rectangular box, but you can see some of this area over here. There's no action going on, and that's just going to take extra time we don't want. So let's go with a bounding polygon. And so that's going to give us something, a little kind of four-sided figure here that cuts out that area we don't care about. However, these edges are right up on the net, so I want to give myself a little bit of a cushion. So let's do 1.2 millimeters. Hit preview, you can see what the bounding box is going to look like. It looks great. Say OK, and it's going to give me some information on simplification. I'll just click OK for right now. I'll explain what that means in a moment. Now it's going to say which solver do I want to use. That's Axiom. The stack-up I'm using is the stack-up information that came through with my import I ran earlier. And hit the Create button. Now before it was prompted me about simplification. This is what it's doing. It's actually looking at these nets, looking at the geometries, and giving me suggestions based on the geometries it sees. I like all the suggestions it gave me. I don't need to make any edits to it. The basic idea behind this is just making my geometry simpler without changing the basics of the geometry, just so it can run the EM simulation faster, but without losing any accuracy, or at least not a significant amount of accuracy. I say OK. Now, everything's done. I can click OK. All my ports are set up. I am ready to go for EM simulation. I can hit the Go button right here, right now, but that's going to take a couple minutes to sim, so we'll skip that step. And I just wanted to highlight one other area, and that is how we've improved the meshing of it. So here, if I look at this same structure that I've been demonstrating so far, here it is in V13. And using the V13 mesh algorithm, you can kind of get a picture of what the mesh looks like. It's good, but it's a little bit busy, and we're going to end up with about 80,000 unknowns. We go over here to V14, the latest and greatest. We hit the mesh on that one. You can see very, very quickly that things are a lot simpler. This is where a lot of that shape simplification came in handy, and we're down to about 20,000 unknowns, so about a quarter. So you take away 75% of the unknowns, that's going to increase your simulation time incredibly. So we're going to have a much faster answer without losing much accuracy. So as you can see in just the last few minutes, we started with basically pointing to a PCB file and have gone from there to a full EM simulation, and all I have to do is hit go to get my results. It was a very simple process. I hope you enjoyed this video. If you want more details, go to our website, awr.com, to get more information or contact your local sales representative. Thank you for your time.